Okay, so this is still day 2 of Leetcode 75. We're doing 841 keys and rooms. I gotta give a great big shout out to Eric for actually doing this so I was doing a Leetcoding session with Eric, and he solved this by himself, and I wussied out and I looked up the solution, and he was like basically right. So I think it's a really fun problem. I think it's really cool. It's pretty simple too, once you kind of understand it. So let's get into it then. Okay, so keys and rooms. So there's n rooms that are labeled from 0 to n minus 1, and all the rooms are locked except for room 0. So your goal is to visit all the rooms. However, you cannot enter a locked room without having its key. When you visit a room, you may find a set of distinct keys in it. Each key has a number on it, which denotes which room it unlocks, and you can take all of them with you to unlock the other rooms. Given an array of rooms where rooms of I is the set of keys that you can obtain if you visited room I, we have to return true if we can visit all of the rooms and false otherwise. So we can see for this example of rooms here, we have access to the 0th room already. This gives us key 1, so room 1 key. So then we go to the room 1, we can visit the room 1 from this. Using that key, we can get the second room key from there, and then using, going into the third room, going into the second room, we're able to go into the third room, and we are able to visit all of the rooms using the keys given. So we can see an example where we can't do this, where we're able to go into 1 and 3, so that's here and here, but we're not able to go into the second room because none of the rooms that we look through have the second room's key. Only the room 2 has their own key, meaning that we can't go into it. So then we will just return false. Okay, so this uses an algorithm concept called the depth first search. So essentially, you have a stack that you're keeping track of, which is all of the nodes, right? Like, think of it as like we're doing basically like a graph search right now. So we are trying to see how far we can go into this graph using the nodes and the vertices, right? And the nodes and the edges. So we're trying to see how far we can go into the tree, go through one level, right? So like, say like we had like, a root here, and then we're able to go to like 2 and 3, and we're able to go to like 4, 5, and 6. So what we'll try to do is we'll try to traverse down from 1, 2, and 4, then maybe go 3, 5, and then go 3, 5, and then if we're not able to find anything, then we'll go back up to 3 and go to 6 instead. So that's the concept of like a depth first search, and we make use of a stack or the values that we've seen so that we can ensure that we're keeping track if we're able to visit all the rooms or not, because that's what we're trying to see. We're trying to maximize the amount of rooms we can visit in this problem here. Okay, so let's get started. So we said that we needed to have some sort of like scene set, right? We wanted to get like all of the distinct rooms out of it. We don't really care if we can get multiple keys out of it. We just want to see if we're able to visit every single room. Another thing we're going to need is a stack. So the stack basically just says like, okay, this is the next room you need to go into, right? So we already said that we're able to go into the 0th room. So we can just say we can add that to our stack, like say, hey, go visit the 0th room. So while the stack still exists, right, what we're going to do is we're going to pop the stack, and we're going to get that value. Okay, so let's say this is the node that we want to look at. Now, next thing we want to take into account here is, okay, so let's go through all of the values that we found out of that node. So when we go to this node here, this is the 0th node, we see 1 and 3. So let's iterate through those values. So we're going to say for neighbor in node, we're going to essentially, add that we've seen this neighbor, and we're going to add that neighbor into the stack as well to say, hey, go inside of that neighbor and see what kind of keys we can get out of that as well. And then finally, we're going to return whether the length of scene is equal to the length of the rooms that we have. Yeah. Okay. So for neighbor and room of length, because we want to access that index, and we want to basically, what we're trying to see is the length of scene. So that means that we visited all the rooms if the length of scene is equal to the length of the rooms, right? Because that's just getting all the indices, and that's just trying to see like, oh, are we able to go inside of every single room? We can run here. Oh, rooms. Maybe, I think there's a condition I probably forgot here. Or I think there's a condition. What is the condition? These are fancy debugger. Very luxurious. So we popped 1. We got 2 into here. 2 is in our stack. We get 3. Oh. 3, yeah. Three. Oh, probably because yeah, we want to say that we've seen 0 as well. Oh, okay, well, we can do this. Okay, that second case is not working. Let's do some live debugging. We get 3 as well, and we want to add 3 into the stack. So we pop 3 out because we want to look to see. Oh, yeah, that's true. So if neighbor not in scene, yeah, there we go. Okay, oops, that was okay, right. Oopsie. Yeah, so essentially, like, we don't want to keep adding the neighbor in every single time, because that would kind of defeat the purpose. Because we just keep going into a repetitive cycle where we keep checking that neighbor, and like they already told us the information. It's kind of like interrogation, like we just keep interrogating the same person, and like they don't have any more information than what we already got out of them, so we need to be able to call that off. So yeah, let's run through the solution real quick again. This is a very long video once again. So essentially we have a stack. Okay, so essentially we have a bunch of rooms. We have access to the first room, so we want to showcase that, okay, we have access to the first room, let's go into the first room, and then going into that first room will allow us to see if we can go into any other rooms. So we add those as options to go into. So that's why we're adding it into our stack. Our stack is just, where do we go next? And scene is just a checklist that keeps track to see if each room is able to be visited or not. And that's why at the end we check to see if the length of scene is equal to the length of the rooms, because that means that we visited all of them. And we only add to the stack when we haven't seen this neighbor yet appear at all, just so that we don't get into a recursive cycle, or a repetitive, or an infinite loop essentially. And yeah, we can go into each room and we can look at all the neighbors that it has keys for. And yeah, that is the solution for keys in rooms. I think it's pretty funny, or I think it's pretty like cool, honestly. And yeah, shout out again once again, shout out to Eric for solving this. And yeah, hopefully we can make more videos. Thanks.